Assalamualaikum and a very good evening to everyone. I'm from Group 2 SN10 Sodium Berhad. We'll be presenting hydrochloric acid production for subject ECH3123 microbalance. And our group is consist of 5 members, starting from me as leader, which is Amir Farida Rasman, as for the scriber, which is Sophia, and the rest of the team members, starting from Limai Chen, Ahmad Fahmi, and Shamini.
What is hydrochloric acid? Hydrochloric acid, which its formula HCl, is called muriatic acid, which means it's a spirits of salt. It's a colorless and pungent solution, which means it has a strong smell or taste. It's a strong acid found in gastric acid and used in labs and industries.
General overview. Hydrochloric acid is a colorless solution with a distinctive pungent smell. The chemical formula is HCl and the structure is like this. The aim for this study is to design a chemical plant for hydrochloric acid production from NaCl and water using direct synthesis.
Next, I will talk about the method used to produce hydrochloric acids. First, for the condition, the feed material is sodium chloride and water, and the production per annum is 1.5 million ton, and the method used here is direct synthesis. So the process that we use to produce hydrochloric acid is by using direct synthesis process. By using this method, electrolysis of sodium chloride solution generate hydrogen and chlorine gases at the respective electrode. The hydrogen and chlorine gases are then directly combined in a control reaction to form hydrogen chloride gas. This HCl gas is absorbed into water in adsorption tower, yielding hydrochloric acid with concentration of 37% or higher. This method is efficient and commonly used for large-scale industrial production of concentrated hydrochloric acid.
Next, for material safety data sheet, for the first material, it is sodium chloride, NaCl. Its hazard is when heated to decomposition, may emit toxic fume. Next, it may evolve into chlorine gas when in contact with strong acids. For its precaution, use protective clothing in area with dust NaCl and avoid contact with aluminium or carbon steel to minimize corrosion. Lastly, for its treatment, rinse with plenty of water, and if digested, drink water to dilute the ingested sodium chloride. For the H2O, it can cause burns to skin if heated to boiling. Prolonged exposure to vapor may cause skin dryness, tearing, and blurred vision, and excessive inhalation may cause drowning. For its precaution, do not drink, do not be exposed for too long, both liquid and vapor form. For its treatment, rinse with normal saline solution or plenty of water, and wash thoroughly with water and mud soap. Following that, for hydrogen gas, its hazard is extremely flammable gas. Pressured gas may explode if heated and cause asphyxiation when inhaled. For its precaution, avoid inhalation, prevent from entering sewers or basement to avoid accumulation. For its treatment, apply artificial respirator and apply first aid to cover injured areas. Next, for chlorine gas, its hazard is may cause fire, may explode if heated and compressed, cause severe skin burns and eye damage, fatal if inhaled. Its precaution is wash hands thoroughly with soap, use and store in a well-ventilated area, and wear protective clothing. For its treatment, wash with plenty of water, remove contaminated clothing, and seek medical attention if inhaled. For the last two, which is hydrochloric acid and sodium hydroxide, let's look at hydrochloric acid. Its hazard is it is corrosive, it causes severe burns, and its vapor is extremely irritating. For its precaution, wear protective clothing when handling and do not dispose in drain or any body of water. For its treatment, flush contaminated area with plenty of water, absorb the spillage with an inert materials, and neutralize the spillage with soda or lime. For sodium hydroxide, its hazard is it is harmful to aquatic life, it causes severe burn, and its vapor is extremely irritating. For its precaution, immediately call poison center, wear protective clothing, and do not dispose in drain or any body of water. For its treatment, flush contaminated area with plenty of water, absorb with dry sand or any non-combustible material, and neutralize the spillage with diluted acetic acid.
For overall process, we have 5 units. The first one is reactor that undergoes electrolysis with composition of 0.991 mol per mol H2O and 0.009 mol per mol NaCl. Next 4 units are combustion chamber, cooling column, absorption tower, and scrubber with their respective temperature and pressure. The table below shows boiling point and solubility of water towards each component.
Alright, so now I will be explaining about the reactors. As for the unit process for reactor, we use electrolysis for this process, and as for the information of the inlet stream, we have the feed, which is 100 mol per hour. We have pressure in condition of 1 atm with a temperature of 25 degrees Celsius. We also have the fractional conversion of sodium chloride, which is 90%, and we also have the chemical reaction that occurs in this unit process, which is sodium chloride react with water to produce sodium hydroxide and hydrogen gas and also chlorine gas. As for the inlet stream, the component that exists is water and sodium chloride, which is in stream 1, got the pressure and temperature of 1 atm and 25 degrees Celsius with component of water and sodium chloride, which is, as for sodium chloride, the mole flow rate is 99.1 mol per hour. As for sodium chloride, the mole flow rate is 0.9 mol per hour. As for stream 2, the pressure and temperature is also the same, which is 1 atm and the temperature is 25 degrees Celsius. Hydrogen gas is 0.405 molar flow rate, which is mole per hour. As for chlorine gas, the molar flow rate is 0.405 mole per hour, which the total can be concept to 0.81 mole per hour for stream 2. As for stream 3, the total molar flow rate is 99.19, which is comprised of sodium chloride with a molar flow rate of 0.09, water with a molar flow rate of 98.29, and sodium hydroxide with the molar flow rate of 0.81.
So the reactor 2 is combustion chamber, in which its intent is to produce HCl, hydrochloric acid, from H2 and Cl2, hydrogen and chlorine. So the informations are: feed is 100 mole per hour as per our assumption, pressure is 2.5 atmosphere, temperature is 2400 Celsius, fractional conversion is 99.8 percentage, which I got from the internet, and the chemical reaction is H2 plus Cl2 is equals to 2HCl. The combustion chamber has two streams, stream 1 and stream 2, which is inlet and outlet. So the inlet stream has two components, which is H2 and Cl2. The H2 has a composition of 0.98 and the Cl2 has a composition of 0.02. And stream 2, which is the outlet stream, has three components, which is H2, Cl2 and HCl. And the purpose of this is to find the molar flow rate of the stream 2, which is N1, N2 and N3 for H2, Cl2 and HCl. So as usual, I'll be using degree of freedom, and I've used extent of reaction method. So the unknown is 3, N1, N2 and N3. Number of independent reaction is 1, which is H2 plus Cl2 is equal to HCl. Number of independent reactive species is 3, H2, Cl2, HCl. Number of independent non-reactive species is 0. Other relation is fractional conversion, and the total is 0, which means we can solve this reaction. So let's start from stream 1. It has a pressure of 2.5 atmosphere and temperature is 2400 Celsius, which remains unchanged for this reaction. So the components we got two. To find the molar flow rate, I've times both the mole fraction, which is given, with the feed, which is 100 mole per hour. And then from the stream 2, as I say, the pressure and temperature is unchanged, and the H2, Cl2 and HCl is to find the molar flow rate for H2, Cl2 and HCl, we will be using the fractional conversion. So the formula for fractional conversion is equals to moles reacted per moles feed. The moles feed is 100. So we will get the moles reacted 97.804. So to find the molar flow rate in the stream 2 for hydrogen, we will be minus H2 from stream 1 minus 97.804. We will get the answer 0.196. In stream 2, we will be using this, since it has the same molar composition for H2 and Cl2, the molar flow rate is same for both 0.196 and 0.196, and we will get the molar flow rate for HCl is 195.608, and the total is 196. We can double check it by using the mole fraction, in which they have given also.
Next, I will talk about the adsorption tower. So the intent of the adsorption tower is to convert HCl gas to acid hydrochloric. So the pressure that we use here is 1.1 bar, and the temperature is 25 degrees Celsius. The efficiency of HCl that we found in the journal is 90%, and the solubility of HCl at 25 degrees Celsius is 720 gram per liter. And for stream 1, the basis that we use is 100 mol per hour, and the composition of HCl is 0.99, and the composition of H2 and Cl2 are both 0.005. For stream 2, we can find the mole of H2O by using the solubility of HCl. After we find the volume of water, we can find the mole of the H2O in stream 2. And next, for stream 3, the mole of H2 and Cl2 is the same as the stream 1, and the mole of HCl we can calculate it by using efficiency of HCl. For stream 4, to calculate the mole of HCl, which is acid hydrochloric, we also use efficiency of HCl, which is at 90%. And to calculate the mole of water in stream 4, we can use solubility of HCl. After we find the volume of water in use, we can find the mole of water in use. And finally, we can find the mole of water in stream 4 by minus the value of water in stream 2 to the value of the water that we calculate just now, which is the mole of water that used.
Now the last unit is scrubber. The intent is to improve quality of HCl in liquid by eliminating H2 and Cl2. At stream 1 for basis 100 mol per hour, the composition of HCl entered the unit is 0.51. H2 and Cl2 are 0.1 and 0.4 mol per mole respectively. At the stream 2, H2O liquid entered can be calculated using solubility 720 gram per liter and density of water at 20 Celsius. At the stream 3, molar flow rate for H2 and Cl2 are the same like the one that entered the unit, while HCl can be calculated using the efficiency of HCl, which is 95%. Lastly, at stream 4, molar flow rate of HCl out of the unit also use the efficiency of HCl. For H2O, the water out of the unit can be determined by minus H2O inlet with H2O used in the unit.